Right. ln x is log base e, which is 2.718, and logx is log base 10. Just to remind you that ln is also called natural log, and log base 10 is called the common log. So mostly just to note, if there is no base, the base is 10. Just like if you're looking at a root, if there's no number, it's a square root. Domain of ln, let's just draw ln. Remember that all bases for logarithms go through 1, 0, because a to the 0 is 1. One thing you do have to remember, a has to be positive and not 1. Okay, so fine, whatever. Domain of ln, then remember it has a vertical asymptote, heads towards negative infinity, so the domain is only x greater than 0. Those of you who like these things, it's parentheses, because you're not including 0. I don't care which way you write it. I usually use inequality notation because that's the way I was trained. All reals for the range. Exact value without a calculator. Remember that ln of thing tells you the exponent. So ln of e to the root 2, this means e to what power is e to the root 2? Well, that would be root 2. Logs give the exponent. Okay, this one, you have to be careful. It's not 3 times 2. You can't cancel the e and the ln until the e and the ln are right next to each other. And remember that that means it's going to pop up as an exponent. So e to the 3 ln 2 is 2 cubed. Okay, with a calculator, it's pretty true. 0.3262. Remember, put all of 5 ln 3 in parentheses. Or you only end up dividing by 5. And multiplying by ln 3, and that's not what you want. Okay, the other thing is make sure that that you close the parentheses for the ln6, because the calculator forces you to have parentheses. Okay, turning things into exponent form. I'm going to just do this for fast. The log tells you the exponent. Just a little note. This is actually a true statement because 4 to the 5 halves means square root the 4 and take the 5th power. Okay, this should be fast. And also, just watch your bases. If it's ln, it's e to the and if it's no base, it's base 10. Remember, you'd use base, go across the equal sign, and then back. Okay, next. Rough sketch of ln thingy. You should be able to do it without a calculator. So this is going to be right for, remember everything x is backwards, and down to. So first off, make a new vertical asymptote. It was at x equals 0, otherwise known as the y-axis. Now it's going to be at x equals 4. So new vertical asymptote, and I'll put a label in it. And then right for means 1, 0 gets moved to 5, 0, not 4, 0. Okay, so, and then move that down. Okay, so we'll go right to 5 and then down 2. And there's that point. And then we just draw in the new vertical asymptote. This is a rough sketch, so you don't have to go crazy. All right, next. Is this one true? No. Addition outside, multiplication inside. So the plus and times sign should have been reversed. Ln of x squared, is that 2 ln x? No. It's close. Ln of x squared is only ln of x times x. Ln of x quantity squared is ln x times ln x. So that's not quite the same. This is squaring the whole thing, not just the inside.